Hello everyone, in this lecture we'll see types of DC motors. So in practical DC motors, the magnetic field is produced by electromagnets rather than the permanent magnets. So DC motors then classified based on the connection of field winding in the motor circuit. So on these basis, DC motors are classified into two types. First one is separately excited DC motors. Separately excited DC motor. Second is self-excited DC motor. Self-excited DC motor. Okay, first we'll understand separately excited DC motor. So what is separately excited DC motor? Why it is called as separately excited DC motor? So first we'll draw the diagram. Okay, this is the diagram of separately excited DC motor here. So this is a one DC source, one variable resistance is the field current, and this is the field winding of DC motor. Okay, so here why it is called separately excited? So a DC motor whose magnetic field, this magnetic field winding is excited from a independent DC electric source. So DC electric supply like a battery. So it is called separately excited DC motor. Okay, now we will understand what is self-excited DC motor. Second one is self-excited DC motor. So in this type of DC motor, magnetic field winding is excited from the same power supply. The magnetic field is excited from same power supply. So this type of DC motor is called self-excited DC motor. So depending upon the manner in which the field winding is connected with the armature winding, self-excited DC motor are classified into three types. So these are classified into three types. First one is series DC motor. Then shunt DC motor. Third is compound DC motor. This compound DC motor again divided into two types, long shunt and short shunt. So one by one we'll see this explanation of this classification: series, shunt, compound type, long shunt and short shunt. Okay, first we'll see series DC motor. First one, series DC motor. So first we'll draw the diagram. Okay, this is the diagram of series DC motor. So in this a DC motor whose field winding is connected in series. So these both are connected in series with the armature winding, so that whole armature current pass through the field winding and is called a DC series motor. So in case of a DC series motor, the field winding carries whole armature current. This field winding carries that whole armature current. Thus, it is made up of thick wire with less number of turns, so that it possesses minimum resistance. So from the circuit we can write armature current so from the circuit we can write armature current armature current IA is equal to ISC is equal to IS. So where ISC is the series field current, ISC is the series field current, IS is the series field current, and IS is the supply current, and IS is the supply current. So supply voltage, we can write supply voltage Vs is equal to EB plus IA RA plus RSE. So here EB is the back EMF, RA is the armature resistance, and RSC is the series field resistance, So this is all about DC series motor. Now we'll see shunt DC motor. First we'll draw the diagram. Okay, this is the diagram of shunt DC motor. Now we can say this is a parallel circuit, so that field winding is connected in parallel with the armature winding. This field winding connected with the connected in parallel with the armature winding, so that the supply voltage is applied across it, and it is known as shunt DC motor. So in the shunt DC motor, the shunt field winding has a large number of turns of thin wire, so that it has high resistance, and therefore only part of supply current flows through it. It has very high resistance, very less current will flow through it, and the rest flows through the armature winding and others. So this current is divided in two parts, so only less current is flows through this field winding, and some current will flow through the armature winding. So for this DC shunt motor, we can write armature current IA is equal to IS minus ISH. This armature current is this IS minus ISH, and the shunt field current ISH is equal to VS by RSH. So that is VS by RSH. Now supply voltage VS is equal to EB plus IARA. So that is EB plus that IA and RA, that armature resistance and that armature current. Okay, now we'll see that compound DC motor. Compound DC motor. This compound DC motor is one which has two set of field winding. So it has two sets of field winding. One is in series, means with the magnetic pole, another one is parallel with the armature winding. So these compound DC motors are divided into two types. So it is subdivided into two types. One is short shunt compound DC, and another one is long shunt compound DC. So this we'll see one by one explanation. Short shunt compound DC. Okay, first we'll draw the diagram. Okay, this is the diagram for the short shunt DC motor. So a short shunt compound DC motor is one which only shunt field winding is parallel with the armature winding. Only this shunt field is parallel with the armature winding. And a long shunt. Okay, let's see the diagram for the long shunt. Short shunt and long shunt compound DC motor. So for that short shunt, armature current IA is equal to IS minus ISH, and series field current ISC is equal to IA. That this ISC is equal to IA, and shunt field current is ISH is equal to VS minus ISC RSC by RSH. That ISH, this current is equal to that VS minus that drop here, that ISC RSC, that ISC and RSC by RSH. Then supply voltage VS is equal to EB plus IARA plus ISE. Now we'll see the equation for long shunt. So here for armature current is equal to IS minus ISH armature current. That this armature current is divided, so that we can write IS minus ISH, this ISH, and series field current ISE is equal to IS only, and that shunt field current ISH is equal to VS by RSH, and supply voltage VS is equal to EB, that back EMF, plus IA RA plus RSC. So these are the equation for short shunt compound DC motor and long shunt compound DC motor. These are the types of different DC motors in electrical machine. Thank you everyone. If you like my video, kindly subscribe my channel.